Okay, today's lesson is 5.4, Sum and Difference Identities. We're going to talk about the first objective, which is to just use these identities to evaluate trig functions. So, to go over first, you will not have to memorize these identities, but you do have to be able to copy them correctly. So, to somewhat help you copy that, I want to point out something about the identities that might help you remember that. So first off, we have the cosine sum. It says cosine alpha plus beta. Greek letters are often used to represent angles in math because we run out of letters in the English alphabet. Anyway, so we have the cosine of alpha plus beta, and the formula says, or the identity says, that it's equal to the cosine of alpha cosine beta and the sine alpha sine beta. So what I want to point out to you, and look, it's the same thing on the other side with the difference, but there's a plus sign here when the trig functions are the same. Okay, so cosine alpha plus beta is cosine alpha cosine beta minus, and if it's a minus sign here, it's going to be a plus. And then when you get to the sine function right below it, sine of alpha plus beta, the trig functions are different. So it's sine alpha cosine beta. Alpha and beta always go in order. And then cosine alpha sine beta with both of them. And so when the trig functions are different, sine and cosine, then the sign between stays the same. So sine of alpha plus beta is plus. Sine of alpha minus beta is minus. The tangent becomes, it's actually a fraction, and on the top, it looks like what it starts. So tangent alpha plus beta on the top is tangent of alpha plus beta, and on the bottom it switches signs. So over here on the right, tangent of alpha minus beta is going to be tangent alpha minus tangent beta, and then it changes the sign on the bottom when you multiply the two together. So just knowing some little details about it might help you copy it correctly. Okay, so when I go through these problems, I know that identities don't need to look at them, but you've got a sheet that I've given you that you should keep handy with you and know it. And the more problems you work, the more you look at that, the more familiar you're going to be with all the identities. Okay, so pause 1 second. Okay, so these identities, as I said, are on your sheet, and they're at the bottom of the first page highlighted in green. It's the green section. Okay, so that's where all of these are coming from. So as I work these problems on the video, I've kind of color-coded the steps because I want to make it easy for you to figure out what's going on. So whenever I do the problem, the first thing I'm going to do is find two numbers on the unit circle that correspond with the angle. Then I'm going to apply the formula or identity, however you wish to think of that. Then I'm going to evaluate, and then I'm going to simplify. So watch what I mean by that. This first one, 1A, says find the exact value. Okay, y'all, so exact value means you aren't going to have any decimals. You can't be rounding. Most likely, a lot of times, you're going to have radicals in your answer. Okay, so if I want the cosine of 15 degrees, then I need to find two numbers on the unit circle that give me 15. Okay, well, if you can use, the easiest angles to use are those in the first quadrant. So if the smallest one in the first quadrant, of course not 0, is 30, then to get to 15, you're obviously going to have to subtract. So the two numbers in the first quadrant, you can use any numbers you want to, but the first quadrant's the easiest, that are going to subtract to give me 15 are 45 and 30. So that means that the cosine of 15 is the same as the cosine of 40 minus 30 degrees, of course, in each case. So applying my cosine formula means the two cosines come first. Cosine of 45, cosine of the first angle, cosine of the second angle. When the trig function's the same, I change the sign, so that's going to be plus. And then the sine of the first angle and the sine of the second angle. Okay? So the next thing you're going to do is evaluate each of those. So I always put parentheses in this step, and it's coming straight down. What's the cosine of 45? What's the cosine of 30? Okay, using your unit circle, you should know that. Cosine of 45 is square root of 2 over 2. Cosine of 30, square root of 3 over 2. Sine of 45, and the sine of 30. And then I will tell you, y'all, most often, when you do these problems, the bottom, these two will be the same every time, whatever these numbers are. It's not that they're both going to be 2s, but if this is a 2 and that's a 5, then that's going to be a 2 and a 5 as well. So you will have the same number on the bottom. In this case, it's going to be 4, and you're just multiplying it out. When you multiply these out, square root of 2 times the square root of 3, you can do it on class calc, but if it's under the radical, it stays under the radical. So that means I'm going to have the square root of 6 plus the square root of 2 all over 4, and that's what we have. Now, these tend to freak people out a little bit. 1b, sine of 5 pi over 12. But find two numbers. Now, I'm going to tell you how to get to this, to find two numbers on the unit circle. Find two numbers that add up to 5. And there is, of course, more than one. But the ones that come to my mind first are going to be 3 and 2. And then I'm going to put those numbers over 12. And when I do they reduce to numbers on the unit circle? Well, 3 pi over 12 reduces to pi over 4, and 2 pi over 12 reduces to pi over 6. So that means that those two numbers, pi over 4 plus pi over 6, which are numbers on my unit circle, will add up to 5 pi over 12. So anytime you're going to pick two numbers, if you're dealing with 1 over 12, pick two numbers that add up to whatever your numerator is, put them over 12 and see if they reduce to something. Okay, you're not going to have a problem that it can't be done. Okay, so that means the sine of 5 pi over 12 is equal to the sine of pi over 4 plus pi over 6. And now I'm going to apply the formula, which says the sine of the first angle plus the cosine of the second angle. Trig functions are different. Sine stays the same. And then the cosine of the first angle and the sine of the second angle. And then I'm going to evaluate. Sine of pi over 4, cosine of pi over 6, cosine of pi over 4, and the sine of pi over 6. So funny enough, these two have to be very similar, the same problem. They probably, we won't go there. All right, so that gives me the square root of 6 plus the square root of 2 all over 4. All right, so sometimes you need to be able to go backwards. So you've got to be familiar, as I keep saying, with these identities. Okay, pay attention. But this first one says find the exact value of cosine of 7 pi over 8, cosine of 5 pi over 12, plus sine of 7 pi over 8, sine of 5 pi over 24. I said 12 back there. Sorry, it's 24. Okay, but notice these two angles are the same, and these two are the same. This is one of my identities. Okay, and I have the trig functions that are the same. Trig functions are the same, so I know this is the cosine formula, and I know the two angles involved are 7 pi over 8 and 5 pi over 24. And this is what I'm telling you. When the trig function's the same, the sign in between them is different. So I know this is going to be minus. So when you subtract 7 pi over 8 minus 5 pi over 24, I don't know why I want to keep saying 12. Okay, y'all, in class calc, if you just put 7/8 minus 5/24, it will give you, well, actually, it'll go ahead and reduce it, but I guess I did it in my head. So I got cosine of 16 pi over 24. If you get your common denominator, class calc will go ahead and reduce that for you. But you put the pi back in, and that's the cosine of 2 pi over 3. Now, I'm pointing this out to you because in Delta Math, when you do your homework, you actually stop at this step right here because the directions say rewrite as a single trigonometric expression. These directions say find the exact value, so you would go one step further and say that it's -1/2. So you got to pay attention to the directions. Here, 3b says simplify it. Well, it's got to be a tangent formula. And as I pointed out to y'all, in the tangent, it's the same as what you see on top. So I know it's going to be I did not mean to do that. My hand slipped. Okay. I know it's going to be the tangent of 6x minus 7x. Okay. And 6x minus 7x is tangent of -x. And it's never simplified if you leave anything but x or theta in there. So that negative either disappears or goes away. Tangent is an odd function, which means my negative goes out front. And that is your answer. Okay. Now, another type of problem that you have with this is something that looks like this. Let me go back up just a tad. Find the cosine of u minus v, given that the sine of u equals 1/5, with u being between 0 and pi over 2, and the sine of v equals negative 5 over 13, with v being between pi and 3 pi over 2. So there's a lot of information, but if you will just take it step by step, it's not that bad. So the first thing, part A, says find the cosine of u minus v. Okay, well, if I'm going to find the cosine of u minus v, that is my difference, my cosine difference. So I'm just going to apply the formula, which is cosine of the first angle, cosine twice. Cosine of the first, cosine of the second, plus sine of the first, sine of the second. And my next step is to actually evaluate that. Okay, well, this is where it kind of gets a little bit tricky. Okay, so they gave me the sine of u. So if you want to, you can go put that in there. And they gave me the sine of v. So you can put that one in there. But how in the world are you going to get the cosine of u and the cosine of v? So I'm going to start off with u. Okay, they tell me that the sine of u is 1/5. And if the sine is 1/5, then that means that the top is y and the bottom, is r. Okay, so I'm going to go back over here to my x squared plus y squared equals r squared. And I'm going to plug in for y and r. So that's going to give me x squared plus 1 squared equals 5 squared. When I subtract my 1, I'm going to get x squared equals 24. I'm going to take the square root of both sides. And I've got to remember my plus or minus 2 square roots of 6. Now, how do I know if I need plus or minus? Well, that's what this is telling you up here. The fact that u is between 0 and pi over 2, well, that tells us it's in quadrant 1. And in quadrant 1, my signs are positive, positive. So that means I want the positive 2 square roots of 6. So that means I can find the cosine of u, because the cosine of u is x over r. So that's going to be 2 square roots of 6 over 5. Now we have to go do the same thing with v. All right, here they told me that the sine of v was negative 5 over 13. So again, that's y and that's r. So I'm going to come over to the side, and x is what I'm looking for. So I'm going to have x squared. And remember, y'all, this negative here, you can ignore it, okay? It's easiest if you feel led to put it up there, put it up with the top, because r is never negative, okay? But more importantly, when you plug it into x squared plus y squared equals r squared, when you square a negative, it is always positive. So I tell people to ignore it, because you mess up when you don't ignore it. Most people do. Anyway, so that's going to be 5 squared, and that equals 13 squared. Well, 169 minus 25 means x squared equals 144. And when I take the square root of both sides, I get x equals plus or minus 12. Again, how do I know if I want positive or negative? I got to go back up here. V is between pi and 3 pi over 2. Well, that's quadrant 3. And if it's quadrant 3, my signs are both negative, so that means I want a negative 12, and that means the cosine of v is going to be negative 12 over 13. Got to pause real quick. So our next step after this is to simplify this step. And if you notice, as I was saying, the denominator of this term and the denominator of that term will be the same most of the time. So if it's not, then you've done something wrong. So just keep that in mind. So on the bottom, we have, well, on the top, we'll start with the top. When I multiply, no, so just to remind you real quick, y'all, what's on the outside? It's not under a radical, so it stays on the outside. So that's why negative 12 times 2 is your negative 24, square roots of 6. And then 1 times negative 5 is going to be minus 5. And 13 times 5 is 65. So that's what we have. Now, this next one is applying the tangent formula. So we have the tangent of u minus v, okay? And again, think about it's a tangent difference formula. So I'm going to apply that formula, which is the tan of u minus the tan of v over 1 plus tan u tan v. And we're using the same problems that we did up here Okay, so I'm going to be using this was my V and this was my X. So when I go to this next step where I'm evaluating, all right, what is the tangent of U? Well, the tangent of U came over here. So that is Y over X. And Y is 1 and X was 2 square roots of 6. So when you rationalize that by multiplying by the square root of 6 over the square root of 6, you're going to get the square root of 6 over 12. So the tangent of U is a square root of 6 over 12 in both places. And then to find the tangent of V, then Y in this case was technically negative 5, but I wrote 5 and the bottom is 12 because they're both negative. So tangent V is 5/12 in both cases. Now, you will have to do this in Delta Math, but hopefully the numbers will be smaller when you do it. So I'm just going to refresh your memory on how to simplify this. Okay. When you have, these are complex fractions, y'all, because I have a fraction within a fraction. So the easiest way to simplify that is to multiply the top and bottom by the least common denominator. That has a denominator of 12. That has one of 12. This term has a denominator of 12 times 12, which is 144. So I'm multiplying top and bottom by 144. And when you do that, this first term, well, we have 12 square roots of 6 minus 12 times 5, which is 60, all over 144 plus 5 square roots of 6. Okay, if you need any help simplifying that or doing it, then please don't hesitate. But we've done this a little bit before where the 12s cancel out when you're doing it. And now I don't have a complex fraction, but I cannot leave a radical on the bottom. So I have to multiply by the conjugate of my denominator, which is 144 minus 5 square roots of 6. I got to multiply the top and the bottom by the same thing when I do that. So on the bottom, I have 144 squared minus, this is, y'all, this is a plus b, a minus b. That gives you a squared minus b squared. Well, when you square this thing, that is squaring the 5 and squaring the square root of 6, which is 25 times 6. Okay, so on the top, I'm going to have the first terms, 144 times 12 square roots of 6. Well, 144 times 12 is 1728. The 6 stays underneath. Outside, 12 times 5 is 60, and square root of 6 times square root of 6 is 6. 6 times 60, 360, minus the inside, and then plus the last. And if you need any help with that, you will have something similar in Delta Math, but the numbers will be smaller. But you have a calculator to do your work for you. So when you simplify that, we get on the bottom 20,586. And on the top, you have 2028 square roots of 6 minus 9,000. And those are big numbers, but that's why we have calculators. Okay, last thing, write as an algebraic expression. So we are doing the same thing, but because we have x's in here, we're going to have x's in our answer. Write each trigonometric expression as an algebraic expression. So it's not going to be just numbers as our answer. Okay, when you look at this, 4a, cosine of the arc sine of 2x plus the arc cosine of x. If you will just think of these two things being angles, then that is like the cosine of a plus b. So how do I apply that formula? Well, that means it's going to be the cosine of the first angle, cosine of the second angle, minus sine of the first angle, sine of the second angle. That is my cosine identity, cosine sum identity. Okay, now what is angle A? Angle A is the arc sine of 2x, and angle B is the arc cosine of x. So then your next step, that's applying the identity, and my next step is to evaluate. And when I evaluate, that's what I'm putting in parentheses. So I got to go figure out, what does this mean? Okay. So what is angle A? And what this says, y'all, if you think about this, is this says, what is the cosine when the sine of the angle is 2x? So I'm going to go draw my triangles, because that's what we do when we have just variables. You can do that with the numbers up above if you find that easier. But sometimes people forget about the plus or minus. So that's why I tend to use the x squared plus y squared equals r squared. Okay, the sine of the angle is 2x. So sine is opposite over hypotenuse. And so to find the third side, you're using the Pythagorean theorem. So if this bottom is a, then I'm going to have a squared, or is it a squared plus b squared, and b is 2x, and that's where people mess up, y'all. And that's equal to 1 squared. So when I subtract to find a by itself, then I'm going to have 1 minus, and this is where people mess up. This is why these parentheses are so important, because when you square it, you have to square the 2 and the x. And so that gives me 4x squared. And so this bottom side is going to be the square root of 1 minus 4x squared. So now this first one says, what is the cosine when the sine is 2x? Well, I look at my triangle, and the cosine is going to be adjacent over hypotenuse. So it is going to be square root of 1 minus 4x squared. Then in the same triangle, what is the sine when the sine is 2x? Well, they just kind of answered it to you, so it's just 2x. Or you can look at the triangle and say it's 2x over 1. Okay, now we're going to go do the other angle. Okay, what's the cosine when the cosine is x? Well, that one is just x. Okay, what is the sine when the cosine is x? Well, that's when I need to go draw my triangle. It says the cosine is adjacent over hypotenuse. So what is the last side? Well, that's easier for y'all to figure out, because that's going to be square root of 1 minus x squared. So what is the cosine? Or excuse me, what is the sine? The last one I'm trying to figure out is what is the sine, and that's opposite over hypotenuse. So that's what we have, and we just simplify, y'all. And to simplify that, you're just taking the parentheses out, and if it's not under the radical, we write it in front. So simplified, my answer looks like this. X times the square root of 1 minus 4x squared, and then 2x times the quantity of 1 minus times the square root of 1 minus x squared. Okay, last one. And then we're done. So we have, this one says sine of arctangent of x minus arc cosine of 1/2. So in a similar fashion, you're going to think about this being angle A and that being angle B. So I'm going to apply my sine formula. And my sine says sine cosine minus cosine sine. Because in the sine one, the trig functions are different, so the sign in between them stays the same. Okay, what are my angles? Well, I go angle A first, which is the arctan of x, and then angle B second. And next I'm going to go evaluate. Okay, this says what is the sine when the tangent is x? Okay, I've got a variable. I'm going to come over here again and draw my triangle. And that's not what I wanted. Oh, too far up. Okay, there's my triangle. All right, tangent is opposite over adjacent. So x squared plus 1 squared equals, and the square root of 1 plus x squared. So that's my hypotenuse. So when it says what's the sine when the tangent is x? Well, what is the sine of that angle here? The sine is going to be x over the hypotenuse, which is x over square root of 1 plus x squared. And this one says, what's the cosine when the tangent is x? Well, the cosine is going to be adjacent over hypotenuse, so it's going to look like that. And now, what's the cosine when the cosine is 1/2? Well, it's 1/2. And what is the sine when the cosine is 1/2? Well, if you don't know it, then you can go draw your triangle. Cosine is adjacent over hypotenuse, which makes the other side the square root of 3. I don't know why I wrote it's the square root of 3 is what that is. So that means the sine is the square root of 3 over 2. All right. And we have to simplify this. So again, each time I have a fraction here, y'all, look what's on the bottom. Over here, 2 times the square root of 1 plus x. 2 times the square root of 1 plus x. So that's what I have on the bottom. 2 plus the square root of 1 plus x. And then on the top, I'm going to have x minus the square root of 3. And unfortunately, I know in delta math you can't leave that radical on the bottom, so I'm going to multiply the top and bottom by that radical, just rationalizing my denominator. And on the bottom, you do not have to multiply it out. 2 times this quantity of 1 plus x squared. And here I'm just going to distribute. So it's going to be x times this minus the square root of 3 times this. So on the top, I have my x times that radical. And then since the 3 is underneath, I went ahead and put it underneath also, because that would be a simpler way. If you want to distribute it, you can distribute it as well. And that is all we have to sum and difference identities. If you have any questions or need any help, please don't hesitate to contact us or come see us. Thank you so much, and y'all have a great day. Bye.